Thank you for inviting me to speak at this meeting. So, why did we choose to support open source hardware? Because a lot of our grant money comes from the government, we feel that we should give back to the community, and open source gives us a nice way to do that. It's also a practical aspect, because theoretically everyone has access to the same hardware, follow-up studies are easier to organize, and making your own hardware is generally cheaper than buying it, if it's even available to buy. So far we've released some of our projects as open source. Our designs are licensed under the MIT or Creative Commons licenses, which state that it's free to use, modify or sell. However, an acknowledgement is needed with the MIT license. The first thing we released is the fractionated dipole antenna, made famous by the Rijmakers et al. Paper. Just as with any coil, we expect you to keep safety in mind when using it. We also have a coil housing to go with it. Then we have some general hardware in the form of a power divider, which splits the input power into 4 outputs. But it's easily expandable to more channels because we provided simulation and calculations to do just that. We also released a drive board for our Philips Achieva 7T system. This is actually part of our new modular interfacing scheme, which is still in development, more about that later. This circuit interprets the signals from the scanner system and acts accordingly. It switches the detune and TR switch voltages with a high maximum current in a very fast time. So what do we plan to release in the future? Most of the following designs are already built as prototypes, but for some we're still iterating the designs to remove any initial design flaws and to avoid unexpected surprises. We're almost ready to release all the parts for a modular receive-only interface box, which includes the drive board that I was just talking about, a function board, which supplies the detune voltage to the coils and uses this to check for malfunctions. Then each channel gets its own preamp board, which houses an easily replaceable preamp socket. This socket is currently made for commercially bought preamps, but any custom preamp design that respects this footprint can be used as well. And everything is tied together by a kind of motherboard. Here can be chosen for 8 channels instead of these showing 16 channels, just to get more space between the connectors. And 2 of these boards can then be tied together to get the maximum of 16 channels again. Furthermore, we have things like a TR switch, quad hybrid, but also devices that aid in benchtop measurements, like these EMI field probes, or a testing device for our drive board, which can not only automatically test the drive boards, but can also act as a benchtop replacement for the scanner system. This way, interface boxes and coils can more easily be tested on the bench. It can read things like the internal ID code, check to see if all the timing demands are met, read malfunctions, etc. And of course, being a coil lab, we have some coil designs that we designed ourselves. We would like for at least some of these to be made publicly. So, if our projects are of interest to you, I advise you to visit our GitHub page at UMCU7T Coil Lab, or just follow this QR code. And also, if you have any improvements in mind for our hardware, please don't hesitate to submit your changes. Thank you for listening.